So last lesson we introduced this vertex form, which is our final form for parabolas. And we found out that that form was useful because it gave you the coordinates of the vertex directly. Today what we'll be looking at is some word problems. And in these word problems, each of them will eventually get you to find the maximum or the minimum point. Right? So for example, I think some of these questions are involving like a projectile, like a ball that you're throwing, for example. And this equation is measuring how high that ball is over time. And in this case, you're trying to figure out where the maximum height of the ball is. That would be the vertex. So if you can figure out what your equation is in vertex form, then you know what the vertex is. And you know when that maximum point was and when it occurred. So all of the word problems we're looking at today will eventually lead back to using that vertex form, or at least finding out where that vertex is. Now you'll notice a lot of the other forms do come up today though. So you might have a factored form, or you might just be given the vertex form. But you might need to switch between them as we've been doing in previous lessons. All right, so we'll go through one example and then I have two more that you'll practice on your own. So first example, a ball is thrown from the roof of the school. The height of the ball is given by the equation h equals negative t plus 1 times t minus 5, where h is the height in meters and t is the time in seconds. So you'll notice the equation was written using different variables, right? Normally we use y and then x's. Here they've just switched the variables to make more sense in this word problem. And that's quite common, but nothing changes other than the variable that we're using. All right, so in this case, we know it's a parabola because it has a t times t is t squared. It makes sense that the height would follow some sort of U shape. In this case, they might be throwing it up and then it'll fall back down. So it makes sense that a projectile would follow that. It would go up and then reach a maximum and then come back down. We know that the a value is negative, so it's a parabola opening downwards, which once again makes sense for this scenario. And we're given factored form, right? Because it's two brackets multiplying. All right, let's try and answer some questions. First question, what height was the ball thrown from? All right, so what was its starting height? Right, sometimes you'll hear it called as the initial height. All right, well, it's thrown from the roof of the school, so there will be some sort of starting height, right? Well, let's see here. We have an equation that gives the height in terms of the time. Well, the ball is being thrown at the very start, which would be time equals 0. Right? So t equals 0 means the very beginning, when the ball was thrown, as soon as it left the person's hand. So in this case, let's just make t equals 0. Let's plug in t equals 0 and figure out what is the height at that time. All right, so I take the equation and I just plug in t is 0. Now if I solve my equation, I'll have the height at time 0. All right, brackets first. 1, negative 5. Multiplying, I think my negatives cancel out, and I get h is 5, so that tells me the height is 5 meters at time 0, at the beginning. All right, so that was the starting height. Okay, that makes sense. It was starting on the roof, right? Someone was standing on the roof of the school throwing the ball. So in this case, they were already 5 meters off of the ground. All right, next question. When did the ball reach a maximum height, and what was the maximum height? Okay. Well, let's think about what point we're talking about. We want to find out when it got to a maximum height and how high it was. That's going to be the vertex of our parabola. So we really need to figure out where is the vertex. All right, think about last lesson here for a second. Well, what information do we know? Given this equation, that's all we have to work with. What do we know? It's factored form, so we know the x-intercepts. Right? We need the vertex. Well, if we know x-intercepts, x-intercept is -1 and positive 5, right? Swapping it because I'm taking it out of a bracket. Well, I can start to find my vertex now. I know that my axis of symmetry would be halfway in between. So axis of symmetry, add them, divide by 2. Halfway in between would be, let's see, 4 over 2 is x equals 2. Okay, so I know there's my x-intercepts. My vertex will be somewhere along x equals 2, right? My vertical axis of symmetry. And now we need the y value, though. So we're going to substitute x equals 2 into our equation and solve the y value, like we've been doing in last lesson and previously as well. All right, so I take my equation, replacing x with 2. And solving that guy. Brackets first gives me 3 and negative 3. Gives me positive 9. Okay. So we now know where the vertex is. The vertex was at 2 and 9. Okay, we've found our vertex. Now let's think about what these were standing for as well. In hindsight here, I actually probably shouldn't have used x. We're used to using x, right, for x-intercept. Reality is that it's actually t equals, right? Because in this case, we use t for our variable, right? So t equals 2. In this case, our vertex happened at 2 and 9. And in this case, our x-axis or our t-axis was the time, and our y-axis was the h, the height. So what does this really mean? It means a maximum height of 9 after 2 seconds in the air. All right, so we've answered the question. Right? Started off at a height of 5, and then 2 seconds later, it got up to a height of 9, and that was the highest it got. And then from there, it would come back down again. All right, so at this point, I mean, we could make a vertex equation if we needed to, but we don't. We've actually already answered the question, so we don't need to. Part C, when did the ball hit the ground? Well, once again, we were given the equation in factored form, so we already know our x-intercepts. Right? X-intercepts, -1 and 5, right? That comes right from our factored form. And hold on, the x-intercept, well, that's when the height is 0, right? That's where it's hitting the x-axis, meaning that our y value, our height, would be 0. Okay, -1 doesn't make sense, right? -1 time, right? Our x-axis is the time, right? Or t. So time is -1 second. That makes no sense in this scenario. So you just exclude that one. In this scenario, negative time doesn't make sense. But the other time that we get is we get an x-axis or x-intercept of 5 seconds. So that tells you, oh, okay, when did it hit the ground? After 5 seconds. Then the height was 0. Let's see, does this make sense? It started at a height of 5 meters. After 2 seconds, it got to a maximum height of 9 meters. And then it started coming back down, and after 5 seconds, it hit the ground. Seems to make sense. Kind of check our answers here. Let's see what we got here. Okay, started at a height of 5. After 2 seconds, it got to a maximum height of 9. And then after 5 seconds, it hit the ground again. Now, since parabolas are symmetric, we could actually get another point in here, right? We know that 2 seconds later, it went up to 9. So that means 2 seconds later, it would be back down at a height of 5. So we actually do know that there's another point in here, 4 and 5, just due to the symmetry of the parabola. All right, so there's an example of a word problem. I have 2 more for you guys to practice. Now I will add one more thing in here. In this case, we were given the factored form, right? So it was easiest just to grab our x-intercepts from here. But let's say you didn't have factored form. Let's say that the problem only gave you the vertex form. So in this case, I'll show you what we would do in that case. So I've just taken this equation here. My vertex was 2 and 9, and we had an a value of -1 earlier. So I've just rewritten our equation in the vertex form instead, right? Using my vertex, right? Switching the sign out of the brackets, so +2, +9, and my a value. So if you never had the factored form and you only had the vertex form, and you were asked when did the ball hit the ground, you can still solve it. What you would do here is you would say, hold on, the ball hitting the ground is a height of 0. Right? So here I've just rewritten it using h's and t's, right? Like we were doing. And if the ball hits the ground, the height is 0. So we plug in h is equal to 0. Replace h with 0. Now, the nice thing about vertex form is you can actually rearrange it for t, or for x. Because of the square here, it actually is possible to rearrange it. Okay, we can solve this guy for t. We start by moving the 9 over. Subtract 9. Then we move this -1 over, right? Divide by -1. You can think of it that way. They cancel out. 9 equals t minus 2 squared. Now I'm trying to get t by itself. Next thing I need to do is get rid of the square. And the opposite of a square is a square root. Square root both sides. Anytime you make a square root, you make a plus and a minus. So square root of 9 is plus or minus 3. I got rid of my square. Still solving for t. I add 2 to move it over. Okay, here we go. What do we notice? Well, we get 2 answers because this is representing x-intercepts, right? First answer uses the plus. Next answer uses the minus. Okay, so first one using the plus. 3 plus 2 gives me t is 5. -3 plus 2 gives me t is -1. And well, that's the same values, right? It's the same x-intercepts, which we expect. It's the same graph. And in this case, you'd throw out the negative time. That makes no sense. And you'd say, 5 seconds. So on one of the practice questions, you actually don't have the factored form. You only have the vertex form. So in that scenario, you can't get your x-intercepts just from looking at the equation. You have to actually plug in height is 0 and solve it. And the nice thing about vertex form is you can solve it when height is equal to 0. You just have to move each term over one at a time, square root to get rid of your square. Make sure to add your plus minus from making the square root, and you can solve it that way.